Mathematical odds are defined to be the probability that event occurs divided by the probability that that event does not occur. Usually expressed as a ratio such as 4 to 1, 3 to 1, 1 to 2, commonly used in sports and lots of other areas as well. Let's look at a couple examples. So let's assume Mike Trout has a batting average of 350. Now, baseball batting averages and things are basically just percentages listed in decimal form with 3 decimal places. So essentially that means that 35% of the time Mike Trout will get a hit. And a lot of statistics in sports are empirical, meaning that they're collected from the athlete, having 100 or 1,000 or 10,000 at bats or whatever it may be. But obviously a true probability would be a lot more difficult to calculate and would be based on a lot of different factors. But let's go ahead and determine his odds in favor and the odds against him getting a hit using odds notation. So, as our textbook says, odds in favor would be the probability of A divided by the probability of A bar. And remember, all that means is the probability of the event divided by the probability of the complementary event, meaning everything else. Or more simplistically, since a probability of the event, the complementary event is the opposite percent, you can always subtract that from 1 instead in order to get that. Or in this particular case, we know that Mike Trout's batting average is 350. So and that would be our probability that he gets a hit. So we could write that as 35%, or we could even keep the baseball notation. I'm just going to go ahead and use a percentage, but that would be the probability of our outcome occurring. And the reverse probability in this case would be, opposite from 100%, or, 1 minus the probability of A, which would be equal to 65%. Oops, I dropped my pen on accident. 65% would be the probability that he does not get a hit, always the opposite fraction percentage ratio from either 1 or 100%, depending on the type of numbers you're using. And in this, the percentages will cancel. We could also reduce by 5 since both numbers end in 5 or 0, meaning they're divisible by 5, but that would leave us with 7 over 13. Or if we wanted to write that as a ratio, we could write it as a 7 to 13 ratio. And this would be his odds of getting a hit. And how you can read odds, one of the main points of an odds is to sort of visualize it using simplistic numbers, meaning the odds that he gets a hit are 7, the odds he does not are 13. It gives us sort of a balance proportional way of examining, what are those chances. When the first number is larger than the second, it means it's more likely. When the second number is larger, it means it is less likely, and more so depending on the scale of those numbers. And the odds against would always be exactly the opposite, which would just be the probability the event does not occur divided by the probability the event does occur. So odds against would be written this way. Basically 13 times he's not going to get a hit, whereas 7 times he would, based on that percentage. Another Theorem 9.8 we might as well address while we're on the subject. Basically, let's say you were given odds and you wanted to return to calculating the probability. Well, what it says is that if the odds in favor are m to n, then the probability of that event would be equal to m divided by m plus n. So let's just check this out, put this to the test, and see if this makes sense. But we calculated the odds that he's gonna get a hit here, and what it says is that if I take those numbers, basically 7 would be m in this situation if I'm using Theorem 9-8, and 13 would be n. I would have that the probability would be equal to m divided by m plus n, which would be 20. So I would get 7/20 as my probability. And if I multiply both by 5, I could see that that would be equal to 35%. Or again, I could use a calculator, do division, whatever. But we see it's consistent, and those odds reflect the true probability. But what's, I think the main thing to keep in mind here is that odds are not exactly the same thing as probability. It's just sort of a different way of presenting the information, an alternative form using a ratio. And the value of this is basically a direct comparison between favorable outcomes and non-favorable outcomes. Instead of a probability, which is the like the percentage based on favorable outcomes divided by the total. So let's just look at example 14 as well. Just looking at another example in sports, but sports books use odds to make money from bettors. So if you wanted to go bet on sports, in some states it's legal, some states it might not be legal, but you could go place a wager, say put $1 on the Lakers to win the championship, or put $100 on whatever. I'm not really a fan of sports betting, so I don't do it, but let's go ahead and just kind of see how it works. Let's assume the Lakers' odds of winning their next championship are stated to be 14-5. Another thing that can be confusing about odds is usually the odds are, with betting and sports books and whatnot, are listed as a monetary gain. And it's something that if you don't really know how they work, they can be really confusing. That's part of the strategy sometimes of betting industry, in gambling industry is to make it not quite clear what's going on mathematically. And you know, betting with sports is very similar to going into a casino and betting on a roulette table or whatever. There's you always have a chance to win, but usually the game is set up against you. So this means that $14 will be paid out for each $5 that are bet in the case that the Lakers win. So essentially there's an underlying probability here, but this is the odds against them winning, because the odds are describing a payout. But basically, let's just use the odds against formula and see what the implied probability would be here. If we were to use the odds against formula, it says the probability of this event occurring would be n divided by m plus n. So the probability of this event, we'll just call this E, whatever, doesn't matter, which is that the Lakers win the championship, is going to be n divided by n plus n. And remember, m plus n. Remember, the denominator is just the sum of the numbers, and the numerator is just one or the other. And usually you can determine which one it is by what makes sense. And since you're going to get paid a lot more money than the number, the amount you bet, you would imagine that the probability that the Lakers are going to win is less. And that's why this is odds against, because they're paying out in the case they lose. Anyways, if we look at 5/19 and go ahead and calculate that percentage, that would give us an answer of about 26.3%. And so that would kind of establish a percentage for what the bettors, what the sports books are assuming the Lakers' probability of winning the championship are. However, usually odds that sports books or whatever, or like if you go to the racetrack or whatever it is, usually they are set up to favor, obviously, those people who are taking bets, because they have to make money. They're making money in this business, of course, for their time and energy. And so this is not the odds the true odds they think the Lakers will win the championship. In reality, it would be actually quite a bit lower. And that's where the margins for their money making comes into play. Anyways, this is not anything that's in your textbook. I thought it was just it's something that you might encounter with odds. One of the most common areas is in gambling. Not that I think that you guys will be gambling. Not that I think there's necessarily anything bad with it, but I don't personally. The reason I'm not a fan of gambling is because usually it's mathematically just stacked against you. Even if you play your cards right, for lack of a better term, you're still probably unlikely to win unless you are cheating. Anyways, and then this all leads up to the idea of expected value, which we'll get to in the next video.